Hello, we are looking at how to use Apache SystemML for machine learning in the data science experiment DSX. This is a README file from GitHub repository, which includes all the instructions you need to set up a DSX account or import notebook in the DSX, the notebook which is part of this GitHub repository. Let me walk through directly into the DSX, where I have already imported the notebook into it, and I can go through the every steps. I have already run all the cells, but you can import it and you can run at your pace. So what is Apache SystemML? Apache SystemML provides an optimal workplace for machine learning using a big data. It can be run on top of Apache SystemML, where it automatically scales your data line by line, determining whether your code should be run on the driver or on Apache's Spark cluster. Currently, team is working on releasing the developments that include additional deep learning with a GPU capabilities, such as importing and running neural network architecture and pre-trained models for training. This code is available for experimental purpose, but it will be released hopefully soon. Currently, SystemML contains many popular machine learning algorithms in the group of regressions, clustering, classification, which can be used as an out-of-box or customized per need. Algorithms are written in Python-like or R-like scripting language, which is very intuitive for data scientists who are familiar with the Python and R. Let's see what is there in this notebook. When you say machine learning, it's about linear algebra, and linear algebra is operation. Most of the operations are matrix and scalar. And when you say machine learning, this matrix linear operation needs to run on the bigger data. So that's where the key thing is. So here, before going forward, since you are in the DSX, SystemML is already part of DSX. Here you are looking at version 0.14. As when you try it out, probably will have a latest version of that time. Okay, so for matrix multiplication, for this exercise, I use NumPy. We can see how this operation can be done. In this case, I use NumPy. We can compare it with the SystemML as well. So in NumPy, we are taking first example like multiply 1 million rows in a matrix of 1 million rows into 1,000 columns. Here, first we initialize the data, and then we are doing the multiplication, and we get the result. Let's increase the data size from 1 million to 10 million. How NumPy provides the result. If I rerun this one with 10 million rows, NumPy cannot cope up with it. As you know, NumPy can run only on the single machine with whatever memory available to it. So with this cluster, or at least the node on which this notebook is running, it cannot contain and it run out of memory. Let's rerun it through the SystemML, same operation. Again, here 10 million rows, 10 million rows, 1,000 columns. We multiply it and we get the results. Why? Because SystemML leverages the cluster, driver, etc., all the memory available to it, and does the operations. Okay, so this notebook contains, for the experiment, for the exercise, it contains linear regression with different flavors. It shows one of the linear regression out of direct solve out of box algorithm, as well. It shows MLN type of interfaces, how it can be achieved. For all these examples, we are using the synthetic data for this exercise, and that data is generated through SystemML. I can show you the script quickly here. Here you define the scripts where training and test data has been generated. Let's go to the linear regression direct solve. So here you see X is input features, Y is output label, A is basically a transpose of X into X, and B is a transpose of X into Y. And what we are doing here, it computes a least square solution where AW minus B is minimized, compute the W such that AW minus B is minimized. So you look at here, this is a script where A is computed, transpose X into X, B is computed, transpose into Y, and then solve method is called where AX minus B, AW minus B is minimized, and then W is computed. We use this script, pass it to the DML, and DML is executed, and then we get a weight. Once we get a weight, we can predict the output and we can plot it using the NumPy plot. You can see here on the x-axis, we'll see the actual value, whereas on the y-axis, you see the predicted value. If both are perfect, then we'll see the straight line. But obviously, it's a synthetic data. We have some Gaussian distribution, so output is little expected output is, or predicted output is little bit different than that. And that is being shown here. SystemML has out-of-box algorithm there. Let me go through it quickly. So this is a SystemML GitHub repository. You look at the SystemML scripts algorithms. Here you'll see the linear regression DSTML. This script is written here. These are all comments. There is a boilerplate code here. This code has been handled for multiple intercept status. But bottom line is eventually we calculate the A and B. Here transpose B and then compute the W. And you get the result. So basically, call these scripts to get the result. So script algorithm, linear regression DS, call the scripts, execute with these scripts, and get the bias and W. And then use this prediction to display the output. And we see the result is similar to what we saw in the earlier case. Let's look at another flavor, batch gradient descents. Here, we initialize the weight, W, with some value. And then for every step size, alpha, we first compute the gradient, dW, which is transpose of X into W is a weight minus transpose X into Y. And then gradient is computed. And in every iteration, we are computing the new weight using the older weight and step size alpha into gradient. And we iterate through until loss is minimized. And this is the script written or is modified from the earlier scripts. Then you pass the script to the DML program and we get the results. And we use a similar plot diagram to display the output. Let's go to the next flavor, which is a conjugate gradient. If you noticed earlier, in the gradient descents, it takes very similar direction many times. So that has been generally solved through the conjugate gradient, where original gradient descents algorithm with the additional enforcing conjugacy resolves these issues, where we compute the alpha and then we get the new direction P so that new weight is computed using the old weight and alpha into P. And that has been addressed by modifying the original scripts in this one and then call the scripts to get the predicted value, and we get the similar output here. Why I'm showing all these three different flavors? Purpose is you can customize, you can write the script and then you can modify or twist it a little bit per your need. And as you see, these scripts are basically the DML declarative machine language with R or Python syntax. You can very easily twist it without doing too much modification. One script written here, you can twist it. Even the script which is provided through the SystemML out-of-box, you can even customize it very easily. Next one is how you can do the MLN interface for the linear regression. SystemML has implemented MLN interface for a few of the algorithms, and linear regression is one of them. What we do in the MLN, basically, we instantiate the object, in this case, a linear regression, and then you pass the training data and do the training with a fit method, and then you do the predict by passing the test data and get the predicted value. Once you get the predicted, you can do similarly through the scikit-learn. You can do the prediction, and then you can do the R2 score based on the prediction got through the SystemML or predicted by the scikit-learn and get the R2 score. In this case, we get the 1.0, which is the highest score we can get. And this is not what all we have. We have a lot more. As I said, linear regression was one of the examples. You can visit Apache SystemML where you have a lot of information provided. Here you can see on the home page, you can see how it shows how to install SystemML. There are additional notebooks. You can go there. You can see multiple notebooks for your reference. You can use those. There is a documentation sections. You can visit the latest documentations where you can see how you can run SystemML through different interfaces. There are programming language guides. If you're writing the scripts, you need to know what are the additional functions and how those can be used. Similarly, it shows what are the additional algorithms are defined here. Okay, that's all I have for today. Thanks for your time.